STS-124, with its international crew of 7 astronauts, will bring hope to the International Space Station. The crew will deliver and install the centerpiece of the laboratory complex known as Kibo, the Japanese word for hope. The 35th flight of Discovery marks the 123rd Space Shuttle flight and the 26th shuttle mission to the space station. This will be the second of 3 missions that will complete the Japan Aerospace Exploration Agency's Kibo laboratory. Discovery's commander is Mark Kelly, a native of West Orange, New Jersey, who's making his 3rd flight aboard the shuttle. Kelly is one of only 2 members of the crew that have previously flown in space. He flew as the pilot of STS-108 in 2001, and again as the pilot of STS-121 in 2006. This will be his first flight as commander. Navy Commander Ken Ham will make his first voyage into space as the pilot of Discovery. Ham is a highly experienced pilot with more than 3,700 hours in 40 different aircraft. He will assist with rendezvous and docking activities, and will also fly the shuttle after it undocks and flies a 360-degree loop around the station near the end of the mission. Mission specialist Karen Nyberg will also be making her first flight into space. Nyberg will serve as Mission Specialist 1 and will operate 3 different robotic arms: the remote manipulator system, the space station robotic arm, and the new Japanese robotic arm located at the forward end cone of Kibo. Air Force Colonel Ron Guerin will make his first flight into space aboard Discovery as Mission Specialist 2 and will make 3 spacewalks during the mission. Guerin will also back up Ham during rendezvous and docking and will serve as Discovery's flight engineer, working with Kelly and Ham during launch and landing on the shuttle's flight deck. Discovery's Mission Specialist 3, Mike Fossum, is the 2nd veteran space flyer on the crew. He completed his first flight on STS-121 in 2006, logging over 300 hours on orbit, including 21 hours of spacewalks. Fossum will be the lead for all 3 of the mission's planned spacewalks. The crew of Discovery includes Japanese astronaut Akihiko Hoshide, one of the first Japanese astronauts selected to train for flight aboard the International Space Station. Hoshide will install the Japanese pressurized module using the space station robotic arm and will be the first to float inside the lab once it's opened. One of the major objectives of the mission will be the exchange of Expedition 17 crew members. Station flight engineer and science officer Greg Shamatoff will remain aboard the station when Discovery departs. Shamatoff will spend the next 6 months on orbit, returning to Earth aboard Endeavour during shuttle mission STS-126. Discovery will bring home station flight engineer Garrett Reisman, who has lived on the station since STS-123 delivered the first component of Kibo in March. The STS-124 crew will see its timeline vary from that of recent shuttle flights. The use of a special sensor and laser system to conduct a detailed inspection of Discovery's heat shield will take place later than usual. Because the Kibo laboratory module is so large, there is not enough room in Discovery's payload bay to carry the 50-foot-long orbiter boom sensor system robotic arm extension that is used to perform the detailed inspection of the shuttle. The crew of STS-123 left the boom extension on board the station in March, so the crew of Discovery could use it during this mission. Once Kibo is installed on the station, the boom will be returned to Discovery and used to inspect the heat shield later in the flight. Just before the shuttle docks with the station, Kelly will fly the shuttle to within about 600 feet of the station and perform a slow backflip called a rendezvous pitch maneuver. This space ballet is performed during every mission to allow station crew members to take detailed digital photographs of the underside of the shuttle for analysis by engineers on Earth. The highlight of the mission will be the delivery of the 2nd piece of the Japan Aerospace Exploration Agency Laboratory, Kibo. Kibo Also known as the Japanese pressurized module, is nearly 14.5 feet in diameter and over 37 feet long. The bus-sized module is the largest station component ever launched aboard the shuttle and will be the station's largest laboratory once it's attached.
It's its own little spacecraft in the sense that it has an environmental system, electrical system, its own computer system, its own robotic arm. It's going to be used for fundamental chemistry, fluid physics, regular physics, biology experiments. Some of those will come up at a later time, but it's going to be a world-class laboratory.
The Kibo Laboratory Complex will include 2 television cameras and 2 6-jointed robotic arms, the first of which will be delivered on STS-124. Next year, another shuttle crew will deliver the third and final component of Kibo, an exterior front porch to allow experiments to be exposed to space. Back on Earth, the installation of the large Kibo lab will enable the Japanese flight control team to begin work in earnest from its mission control center in Tsukuba, Japan. There are 3 spacewalks scheduled for the flight of STS-124. Each will last about 6.5 hours. On Flight Day 4, Fossum and Guerin will transfer the orbiter boom sensor system back to the shuttle from its temporary location on the station's truss, where it was stored during the last shuttle mission. The 2 spacewalkers also will conduct further inspection of a damaged solar array joint that enables the starboard solar arrays to rotate and follow the sun. Fossum and Guerin will demonstrate techniques that may be used to help clean contamination from the joint's rotating ring. The crew will then prepare the Kibo module for its removal from the shuttle payload bay. Later that day, Hoshide will install the module on the port or left side of the Harmony connecting module. On Flight Day 6, Fossum and Guerin will install covers and external television equipment on Kibo and remove covers from the module's new robotic arm. The first section of Kibo, the Japanese logistics module, was carried to orbit during STS-123 in March and installed in a temporary parking place on top of Harmony in preparation for delivery of the main Kibo lab during STS-124. On Flight Day 7, Nyberg and Hoshide will relocate the Japanese logistics module to its permanent position on Kibo, using the space station robotic arm. On Flight Day 9, Fossum and Guerin will participate in what is expected to be a truly spectacular spacewalk as they work to replace a depleted nitrogen tank on the station's starboard truss used to pressurize station cooling systems. Guerin will grasp the 550-pound tank while attached to the end of the space station robotic arm. Then, Nyberg will maneuver the arm in a windshield wiper move, carrying Guerin and the tank on a panoramic trip as far as the station arm can reach to a stowage platform on the other end of the outpost, called ESP-3.
So this maneuver right here takes about 20 minutes, and on the top here I'll be almost 100 feet above the station, looking straight down on the aft side of the station and the Earth 250 miles below. So it'll be a pretty spectacular view and a pretty spectacular ride.
Guerin will then take a new nitrogen tank and reverse course, moving from the storage platform back to the starboard truss for its installation and activation.
We tend to get a lot of the accolades, but there are a lot of people that are behind the scenes that are certainly as critical as we are to the success of this mission.
There are people who train us, people who actually manufacture the module, the orbiter, doing work down at the Cape, all the flight controllers here at the Johnson Space Center, as well as in Tsukuba Space Center, who's working really hard, long hours.
Everywhere you go, every center you go, if you go to the subcontractors, everybody from the people that are turning the bolts and the nuts and to the people who are designing things, you could see it in their eyes. You could see how excited they are to be a part of it, because really it's an amazing accomplishment what is being achieved on the ISS through this construction.
Auf dem Weltraumbahnhof Cape Canaveral im US-Bundesstaat Florida laufen die letzten Vorkehrungen für die bevorstehende Mission der US-Raumfähre Discovery. Der Shuttle startet am Abend zu einer 14-tägigen Reise zur internationalen Raumstation ISS. Hauptaufgabe der 7-köpfigen Crew ist die Lieferung eines weiteren Moduls für das japanische Labor Kibo. Insgesamt sind 3 Außeneinsätze der Astronauten geplant. Marsfotos. Die auf dem Roboterarm der Marssonde Phoenix installierte deutsche Spezialkamera hat Bilder von der Planetenoberfläche gemacht. Darauf seien polygone Platten zu sehen, die auf ein Eisfeld unter der Oberfläche schließen lassen, teilte die NASA mit. Die Kamera war vom Max-Planck-Institut für Sonnensystemforschung entwickelt worden und soll bei der Analyse von Bodenproben auf dem roten Planeten helfen.
The shuttle and its crew of 7 is set to launch from the Kennedy Space Center today. It'll deliver the main section of Japan's science lab, Kibo. And most importantly, the mission will take a new pump to repair the station's toilet that's failed in the module.
Sitting on the launch pad at Cape Canaveral, the Space Shuttle Discovery is ready for its latest mission. This time it'll be carrying one of the heaviest and widest loads in the fleet's history. On board will be the International Space Station's scientific crown jewel, a 16-ton Japanese laboratory known as Kibo. Over the next 2 weeks, it'll be the job of these 7 astronauts to add the giant module to the orbiting space station, making Japan a major player in space exploration. But the crew of the Discovery also have another vital mission: to replace a pump for the space station's toilet. It broke several days ago. Ever since then, the astronauts in orbit have been operating it manually, an operation that takes 2 people 10 minutes to complete, and all in zero gravity. The pump is being specially flown in from Russia.
The hardware is being hand-carried from Russia, and the individual bringing it should be arriving in Orlando around 8:30 or so tonight, and then give them an hour and a half or so to get over here, so we expect it to be on dock about 10 p.m. The hardware in total weighs about 35 pounds. The pump itself is about 29 pounds.
The crew will also be taking Buzz Lightyear into orbit. They'll be part of a special educational program aimed at encouraging children to study science. NASA say this is one of their most complex missions to date. Before the end of the year, they hope to launch a further 2 missions with the aim of continuing work on the International Space Station. It'll take another 9 shuttle flights before the orbiting laboratory is completed, and the shuttle fleet is retired in 2010. Andy Gallagher, BBC News, Florida.
This is Shuttle Launch Control at T-minus 3 hours in holding. We have another 47 minutes and 30 seconds left in this particular hold. Launch controllers are still not working any problems that would prevent us from lifting off at 5:02 p.m. Eastern. That being the case, we've brought in Discovery's Flow Director, Stephanie Stilson, to join us to walk us through how we got to where we are now. Stephanie, thank you for joining us.
Sure thing.
So how did we get to where we are now?
A lot of hard work by a lot of people, that's for sure. We've had a really good flow this time around. It's been a very clean flow, and that's reflected in how things are looking right now in the countdown.
And as a matter of fact, we're hearing from even Mark Kelly, commander of Discovery, was saying that, yeah, we were near a historic low, which always makes me nervous when people say things like that. But, so
you and me both.
On hardware issues, so where are we?
Yes, right now we track our problems with what we call interim problem reports, IPRs. And right now we're at count number 73. And the record is actually 76 for the low, and that was actually a Discovery flight as well, STS-124. So we're hoping that we keep going the way we are now, that maybe we'll break that record. That'd be a great thing.
Like you said, we haven't quite lifted off yet, so it's
got a little more time.
Why don't we? I know you have some video to show everybody to walk through exactly what, where we came from and how we're out at the launch pad. So.
Yes, we'd like to do that. That'd be great. Okay, on March 26, external tank 128 arrived by barge from the Michoud Assembly Facility in Louisiana. After spending a week traveling through the Gulf of Mexico and the Atlantic Ocean, the barge is carefully negotiated into the Kennedy Space Center turn basin. The turn basin is located less than a quarter of a mile from the vehicle assembly building, which is the tank's first stop upon arrival at KSC. Once on dock, we use the external tank transporter to move the tank off the barge and over to the vehicle assembly building. This process takes us approximately 2 hours. The function of the tank is to provide propellants to the 3 Space Shuttle main engines. The tank is 154 feet long, 27.5 feet in diameter, and holds over 500,000 gallons of propellant. Once the tank is located in the vehicle assembly building, we attach the sling and start the process of lifting the tank into the test and checkout cell. This is done using a 325-ton and 175-ton crane. The tank weighs over 58,000 pounds empty, and it takes approximately 12 hours to place the tank in the checkout cell. Once in the checkout cell, the tank is inspected and prepared for being mated to the solid rocket boosters. While all of this is happening in the vehicle assembly building, the orbiter is being readied in the orbiter processing facility. The majority of the required repairs, modifications, and system testing occurs in the OPF. Here you can see the payload bay of the orbiter with the orbiter docking system on the left. And as the camera pans towards the aft of the orbiter, you can see the remote manipulator system, or the shuttle arm, in the forefront with the red protective covers that are removed before flight. These technicians are performing tile work on the orbiter and are specifically working a closeout panel located between the belly of the orbiter and the reinforced carbon-carbon panels of the wing leading edge. When all the work in the payload bay is complete, we close the payload bay doors. Here you can see the silver radiators which line the interior of the doors. The radiators provide cooling for the electronic boxes that control all of the orbiter systems. The door being closed in this phase is the left-hand or port door. Before closing the right-hand door, we have to retract and stow the KU band antenna, which is one of the antennas that allows the astronauts to communicate with the team in the mission control while on orbit. The motors that drive the movement of the payload bay doors are designed to work in microgravity and are therefore not strong enough to close the doors here on Earth. So we have what is called a zero-gravity or zero-G system to assist the doors with the closure while being carefully monitored. The yellow structure that you see here is part of that zero-G system. Prior to the arrival of the tank, the solid rocket booster segments are stacked on the mobile launch platform in the vehicle assembly building. The solid rocket boosters augment the thrust of the Space Shuttle main engines during the first stage of flight. Once stacking of the boosters is complete and the tank has been checked out, we begin the process of moving the tank from the test and checkout cell to the integration cell to be mated to the boosters. The 325-ton crane lowers the tank down into position so that it can be bolted to the solid rocket boosters. We have technicians located on platforms around the boosters monitoring the lowering process to ensure the tank is in the exact position required. Once the external tank is mated to the solid rocket boosters, we spend about 2 weeks doing closeouts in preparation for the arrival of the orbiter. Similar to the tank transporter we saw earlier, the orbiter has a transporter as well. The Orbiter Transport System, or OTS, has 76 wheels on 19 axles and was built specifically for the orbiter. Once all the test and checkout of the orbiter is complete, we position the transporter underneath the orbiter. Discovery is then lowered onto the transporter. When secured, the OTS slowly backs out of the orbiter processing facility to make the 30-minute trip to the vehicle assembly building. The transporter can travel 12 miles per hour when it's not carrying an orbiter, but only 2 miles per hour with an orbiter. Discovery is attached to the transporter using the same attach points that will eventually connect it to the external tank. The orbiter is 122 feet long with a 78-foot wingspan and weighs approximately 200,000 pounds. There are approximately 24,000 tile and over 3,000 thermal blankets on Discovery to protect the orbiter from the extreme temperature fluctuations seen on orbit and during re-entry. STS-124 will be the 123rd Space Shuttle flight and Discovery's 35th flight. Discovery spent 170 days in the orbiter processing facility preparing for the task of delivering the pressurized module component of the Japanese experiment module to the International Space Station. The pressurized module is so large that it practically fills the entire payload bay itself. In fact, because of the module's size, we are not able to carry the orbiter boom, which is an extension of the shuttle arm, with us during this flight. Instead, Endeavour left a boom for us at the International Space Station during their last mission. Once the pressurized module is removed from Discovery's payload bay, we will pick up the boom, use it during the mission, and bring it back to Earth. Once Discovery is safely in the vehicle assembly building, we begin the process of lifting the orbiter off the transporter so that it can eventually be attached to the external tank. A sling is connected to the orbiter, which allows cranes to lift and move Discovery into the vertical position. Once in this position, we can then begin the process of lifting the orbiter up and over the transom into the integration cell. It takes approximately 12 hours to lift the orbiter and get it into the mate position. Technicians closely monitor the movement of the orbiter and are in radio contact with the crane operators at all times. The vehicle assembly building was originally built for the Apollo program in the 1960s and was later modified to accommodate the Space Shuttle. It is 525 feet tall, which is large enough to house the Statue of Liberty, and it covers 8 acres in floor space. Once in place, the orbiter is bolted to the external tank and 3 attach points that use frangible nuts. During launch, when the main engines have depleted all the fuel in the tank, pyrotechnics are detonated, which break the nuts, allowing the tank to separate from the orbiter and disintegrate as it falls through the atmosphere. Once the orbiter is attached to the external tank, we begin the process of retracting access platforms in preparation for moving the complete shuttle stack out to the launch pad. On April 29th, Discovery began the approximately 3-mile journey from the vehicle assembly building to Pad A. The stack is moved by one of our 2 crawler transporters. Instead of wheels, the crawler has 8 tracks with 57 cleats per track. Each cleat weighs 1 ton. The transporter is 131 feet long by 114 feet wide, which is comparable in size to the infield of a regulation baseball field. The crawler weighs 6 million pounds and uses 150 gallons of diesel fuel per mile as it travels down a gravel path out to the launch pad. At a speed of less than 1 mile per hour, it takes approximately 8 hours to travel just over 3 miles from the vehicle assembly building to the launch pad. Once at the launch pad, we spend about a month doing full system checkout of the tank, boosters, and orbiter in preparation for today's mission.
You get a couple of nice shots of Discovery there when you run out to the launch pad. And as a matter of fact, something I guess has to do directly with the number of problems you had, or lack of problems.
Lack of problems.
Had,
Let's say it that way. That's a much better way to say it.
Much better way. Good public affairs. We started off pretty much with we like to call them contingency days. That's what we refer to them, but it's padding in the schedule that gives us, if something crops up, it gives us a chance to work it and not affect the overall launch schedule. You started out with 0. And
actually, we started off with 7 going into integrated flow. So we did have 7, and we ended up using 2, which got us down to 5, which actually going into the integrated flow, I'd be very content with just having 5. So even when we came down to 5, that's still plenty of time, and we ended up not even having to use those 5 days. So that allowed us to actually take off the holiday weekend, which was a great thing for all the folks right before countdown to have a 3-day weekend. And yes, as you said, that can be attributed to the great processing flow up to that point, and the vehicle's just behaving wonderfully, so we haven't had a lot of issues that have to deal with.
And that is all good news because it puts us in a good position to be able to launch today if weather cooperates, which it looks like it will, and our transatlantic abort sites, they continue to have good weather.
And we can't control the weather. That's the one thing we can't control.
That's another part of the government I know, does weather modification. All right, well, Stephanie, thank you for joining us and really walking us through how we got out to the launch pad, and well, our fingers and every other appendage we can will be crossed for a good launch today.
Anything you can do, that's great. We want to get off today. It'd be a wonderful day to launch.
So we're here at T-minus 3 hours in holding. This is Shuttle Launch Control. We're joined right now by the STS-124 payload manager, Scott Higginbotham. Scott, thank you for joining us.
Great to be here today.
You're going to kind of walk us through what we're going to see. Actually, what is not seen now, but we'll be seeing when we open the payload bay doors and get to the space station. But first, I think we've got a couple of pictures of what's going on out at the launch pad. It may make you a little nostalgic, I guess, right?
Oh, indeed it does. Back early in my career here with NASA in the late 80s, early 90s, I used to be a member of what was called the ICE team, now is the final inspection team, and so I miss being out there when I see those guys out there doing that walk around. It's a pretty amazing spectacle to be out there under the vehicle as it's starting to come to life.
And they started out this morning at the 255-foot level, moved to the 215 level, the 195 level, which is where, of course, the crew enters the shuttle. They move then to the 135-foot level, and right now they wrap up at the very bottom level, or 0 level of the mobile launcher platform, and they are doing their final inspections there, and should be reporting out in about half an hour or so. But that's what's going on the pad, and they're not working any issues right now that would prevent us from lifting off at 5:02 p.m. today. So, Scott, if you wouldn't mind, we've got a shot of the aft end of Discovery, and if you go up a little higher, we could see the cargo bay, and why don't we talk about what's inside there?
We have an absolutely amazing spacecraft that we're going to be taking up to the International Space Station, the JAXA's pressurized module, part of the Cabot system. It's the largest pressurized component of the International Space Station, and just truly a remarkable machine.
It really will increase the scientific capability on board the station, and it's so big. I'm supposed to say, how big is it? It's so big that it takes 3 flights to be able to take up entirely, and what other international partners back reduced the size of modules, including the U.S. laboratory. Japanese laboratory pretty much stayed really close to the 20-year-old design, is my understanding.
Indeed it did. They stuck with their original plan. They were going to be the smallest, and now they're the largest.
And it has, I'm sure actually we'll walk through it, so why don't we, I'm gonna get out of the way and let you do your thing.
Okay, very good. If we can go ahead and show the video then. This tries to compress what ended up taking about 5 years into about 6 minutes. The Cabot module arrived at the Kennedy Space Center from Japan in late May of 2003. It arrived by ship. It left Yokohama, Japan on the 2nd of May of 2003 and took 28 days to come across the Pacific Ocean, through the Panama Canal, and up to Port Canaveral. We unloaded all of the hardware at the Navy facilities at Port Canaveral. As you can see, they have a rather massive crane there that was very convenient for our use. The Element came off actually 5 days after the ship arrived, because first we had to get off all of the ground support equipment necessary to support that module when it arrived at the SSPF, and get it assembled, and primarily the large rotation stand that the element has sat in during its campaign here. It then came via truck over to the space station processing facility where we got it out of its shipping container, which you can see here.
You can actually see the old, the Japan Aerospace Exploration Agency, its older name, NASDA.
Right. While the element was here, they changed their name from NASDA to JAXA, and so there's still some vestiges of that old agency's logo that you can see around the place. So once the element arrived, we did get it into its rotation stand so that the Japanese technicians could begin their work preparing the module for flight. The module came a little earlier than it really needed to in order to meet up with the Node 2 Harmony module. As they mate together on orbit, it was decided early on in the program that it would make a lot of sense to try to join the two together, at least electrically, to ensure that all of those interfaces were going to work right before we put the hardware up into space. So shortly after the module arrived, we did perform what we called our multi-element integrated tests, and that was in August and September of 2003. And in that test, we also used a simulator of the U.S. laboratory, again, to make sure everything was going to work right on orbit. What you're seeing here now is a scene of some of the Japanese technicians working on the windows of the module. The Kibo has two very large windows that look out over the where the exposed facility hardware will be after the last flight, STS-127. And during the course of the flow, there were a wide variety of tasks that JAXA performed, and some that we actually assisted with, and others we provided advice and support items for JAXA. And over the course of the flow, they installed all of the racks into the module and tested them, not only the racks that are flying up on this mission, the 4, but 7 others that are waiting on orbit for Kibo once it arrives. The flight crew came down numerous times during the campaign, and here they are during their last visit in January of this year. They like to come down and actually touch the flight hardware when they can to practice some of the tools and techniques that they'll use during the flight. Finally, after all the work was done on the 22nd of April of this year, we lifted the element one last time and weighed it. The module weighs in at 32,220 pounds and 12 ounces. And here it is being translated over for installation into our transportation canister, which we use to keep the module dry and cool during the ride from the industrial area here at the Kennedy Space Center out to the launch pad. Of course, this is a very slow and methodical operation, and what you're seeing here actually took place over the course of about 6 hours. And there it is, just getting ready to set down. You can get a scale for how large the module is, as that canister is essentially the same size as the orbiter payload bay. There's Dr. Tanaka, our local resident manager for GEM project. We rotated the canister to vertical, and then on the 29th of April, we departed for Pad A. The journey out to the pad takes about 3 hours to complete. We go very slow to avoid inducing any vibrations in the spacecraft. And we typically go during a time of day where weather is cooperative for us, and in the time of year that we went out here in April, early evening was a good time to go, so you can see us approaching sunset. We take the payload elements to the pad before the space shuttle vehicle arrives. That allows us to get in place and get our canister out of the way long before the shuttle shows up, so that we don't perturb the critical path for the launch vehicle preparations. And there you can see our transporter going up the incline, just like the crawler that carries the shuttle to the pad. Our transporter can adjust to accommodate that tilt as it goes up the ramp. Once we get to the pad, the canister is actually hoisted up into the rotating service structure of the pad. Inside that rotating service structure is a room called the payload changeout room, and inside that room is a 5-story gantry called the payload ground handling mechanism that picks the payload element up out of the canister and takes it back into the pad structure. Once that's complete, the canister is lowered and taken away. And then we wait for the vehicle to arrive. In this case, we waited about a week. The Discovery came to the pad on the 5th of May, and then that large structure that you see there now rotates around the space shuttle. The payload bay doors are opened, and the element is installed into the payload bay of the orbiter. And there is what the PM looked like after we'd installed it into the orbiter and had pulled all the platforms back. That was after we did all of our electrical mates and tests and our final closeouts, final assembly operations. And this is as the doors closed for flight on May 10th. Several of my colleagues and I were there to kiss the hardware goodbye. The next time we'll see it will be tonight, hopefully, when we get on orbit, when it's circling the Earth at 17,500 miles an hour.
That's a good time to see it again.
Indeed it is.
And that brings us to where we are right about now, and it's at about 22 minutes left in this built-in T-minus 3-hour hold. And we're getting very close now where the Discovery's astronauts will be suiting up and getting ready to head out to the launch pad themselves.
Wonderful.
Scott, I appreciate you coming by and walking us through what's inside and what is this whole cargo about, and giving us a little extra information about the final inspection team. Learn something new about you every day.
Well, thanks. It's a pleasure being here. We're all excited on this very historic day for the Japanese space program, and for us it's been a real privilege and an honor to work alongside them as they've prepared this hardware for flight.
Excellent. This is Shuttle Launch Control at T-minus 3 hours in holding. We are just 5 hours shy of the launch of Space Shuttle Discovery on its STS-124 mission to the International Space Station. Discovery is scheduled to do a 14-day mission to the International Space Station, and we have the ability to stay docked for at least going into launch an extra day if needed. And that still gives us 2 weather wave-off days if we're not able to come down on June 14th, Saturday morning, to end the flight. Launch controllers are not working any problems right now that would prevent us from lifting off at 5:02 p.m. Easterns. And we're getting very close to getting video inside the operations and checkup building. In fact, we're so close we're here. There's the STS-124 crew suiting up. That's Commander Mark Kelly. And his pilot, Ken Ham. That's our lead spacewalker for this mission, Mike Fossum. He's had one flight before, actually with Mark Kelly on the STS-121 mission last. There's Greg Shamatoff talking to Mark Kelly's brother. You're not seeing double. He does have a twin, and Mark's flying. And Scott flew last year on the STS-118 mission. Greg will be getting a lot of thumbs up because he'll be spending the next 6 months or so on the International Space Station. He's going to be replacing Garrett Reisman. Aki Hoshide. This is Hoshide's first flight into space. He was born in Tokyo, Japan, but did spend 4 years here in the United States. It's Dr. Karen Nyberg. She'll be making her first flight on this mission. And finally we have Ron Guerin, also making his first flight. He's a colonel in the U.S. Air Force, and he's one of our mission specialists. And we've got the STS-124 Discovery crew walking their way down.
You can see Commander Mark Kelly and pilot Ken Ham leading the way. Greg Shamatoff, our station astronaut, who's going to be switching out. And also Chief of our office, Steve Lindsay. Brent Jett, who's the lead of the Flight Crew Operations Division. And the other gentleman in the blue suit there is Jerry Ross, one of our veteran astronauts and the lead of the Vehicle Integration Test Team office. You can see the crowd of employees from KSC there that will meet them.
you get my message? Okay.
Been told, many astronauts have actually said that doing what we just saw right now, when you line up there and head into the Astrovan, really, that brings it home that you're really actually about ready to launch. This is it's for real.
And the crew's beginning to exit the Astrovan, taking their, you can see their helmet bags that they're carrying over towards the elevator. There we can see them stepping out at ground level at the pad from a little ways away. And they're going to take a look up at their soon-to-be their ride into space, Discovery.
And they're home for the next 2 weeks.
That's right. There we can see Mark as he's climbing in. You can see that's his seat in front of him, so he'll be laying on his back as he climbs in. Kind of an awkward thing. Here he has to grab some handholds that are up above and get his feet in around the stick, which is covered by a red box there. You can see the rotational hand controller, as it's referred to. And you can see in his seat behind him, the orange is the parachute that he will then attach to his harness. If they did have to egress the vehicle, may end up taking that with him, most likely. And if they're just egressing on the ground, obviously, if you're bailing out, you'll definitely be taking that with you.
Yes.
And using it. And there you can see Greg climbing into the furthest seat over to the starboard side, the right side of the mid-deck. Ray Cuevas, number 7, in the white suit there, is helping Greg to strap in. Here we can see Mark Kelly now getting his helmet put on. You can see Kay kind of behind and below him. And John Hazelhurst, just to Mark's right. They're both going to help him to make sure he gets that helmet on with a good seal, doesn't trap any kind of fabric or any other part of the suit in there. You can see Ken Ham now climbing up into his pilot's seat. View looking across the cockpit from the right side. I would imagine the crew looks forward to getting their cooling hooked up, because that's a fairly strenuous maneuver there, getting yourself pulled up into that seat with an extra 100 pounds or more on your body and a constrained environment. So
and you're in the sun.
You're in the sun, and they've been off cooling since they left the Astrovan, so they're probably starting to get a little warm. Mike Fossum climbing in on the middeck and about to join Greg Shamatov, who's got his helmet and gloves on now. Hey, there's Aki pointing to our patch. Proud peacock. Excellent.
He knew you were watching.
Well, we're very proud of him. He's a great friend to all of us, and we're just excited to see him get to fulfill his dream. He was selected by the Japanese Aerospace Exploration Agency in 1999, and then joined our NASA class in 2004, along with Satoshi and Naoko. So Aki's waited quite a while for this, and we're really excited to see him get this opportunity.
An OTC of ECC, MS4 on board 15 seconds ago.
Copy. And double OTC.
Go ahead.
Can you verify 677?
Complete.
Thank you.
$1 billion science lab called Kibo to the International Space Station. The station's crew is anxiously waiting for another piece of cargo, a toilet pump to put in the lone toilet on the space station, which is broken. Okay, among the other highlights of the mission, 3 spacewalks and cleaning part of a solar panel. With a closer look at Discovery's task list, we're joined by our space correspondent Miles O'Brien in Cape Canaveral, Florida. Miles, good to have you with us. Tell us a little bit more about this Japanese lab, because it seems just getting it to the International Space Station is a mission in itself.
It is indeed, Aisha. This is a big piece for the International Space Station. It'll be the biggest laboratory once it is latched onto the International Space Station, and it paves the way for about this time next year for doubling the crew size. Of course, this is a big deal for the country of Japan as well. The Kibo module, which weighs in at 13,000 kilograms, is about the size of a bus, is tucked in very snugly into the back of the Space Shuttle Discovery into the cargo hold. Using robotic arms designed by the Canadians, it'll be latched on. Some bolts will be put in place in the course of some spacewalks, and once Kibo, assuming all goes well, is attached, the capability of the space station, the scientific potential, will increase dramatically. Of course, you alluded to the other issue here. The 7-member crew of Discovery, led by Commander Mark Kelly, perhaps the most glorified plumbing delivery supply outfit in the world right now. On board Discovery is a 15-kilogram part to a toilet, which has remained bulky on the International Space Station, has been so for more than a week. It has been unable to properly it relies on suction to remove liquid waste, and that pump has not operated properly for some time. The crew has come up with some workarounds, which are inconvenient to say the least. They are able to use the toilet, but only with every third use or so, a manual water wash and so forth, and this takes quite a bit of time. Fixing the toilet is obviously a priority. There is only one toilet in the Russian module, Zvezda, and it needs to be fixed. They put in 2 spares, both of those spares broke, and so the part, which was flown from Moscow to Orlando, driven here to the Kennedy Space Center all on Thursday, is now stowed inside Discovery, and it will be attached, if all goes well, as I guess you could say, Aisha, their #1 priority after docking.
Thanks, Miles, for that one. Yeah. Moving on from the toilet, which I'm sure the astronauts will feel like Christmas has come early when that part turns up. Buzz Lightyear, what's this about him going into space, infinity and beyond?
To infinity and beyond, Buzz Lightyear, Aisha. He's on the shuttle. He's on the shuttle. The Disney folks managed to finagle this deal. Buzz will be on the shuttle. We'll see some video of Buzz floating around, and he's there. Disney has an educational component to all this, but basically it's a promotion for a new ride at Disney World, which involves all the Toy Story characters. But I'm sure it'll be nice to see Buzz, kind of floating around in space, so we'll see that as well. So, yeah, we got something for everybody here. We got a broken toilet, we got a great new science module, and we got a floating toy.
It's a wonderful piece of cross promotion, if I can even get the words out, getting Buzz into space. But just to get back to the wider mission, do you think that they'll be on track to get everything to the space station fully stocked before 2010 when they retire the shuttle?
Yeah, it's interesting. We were just talking about that today. This is the midway point from the post-Columbia world when this decision was made. Back in February 2003, we lost Columbia. Shortly thereafter, they decided to retire the space shuttle at the end of 2010. This is the midway point. We are half as many flights left. And basically, they're on track to pull all this off. It's still a relatively aggressive schedule, and, this thing has a million moving parts in it. And things can go wrong and things can lead to groundings, but they have a fair amount of margin built in. And the hope is that they're going to be able to build out the station, use all the shuttle-required missions, get them done in time, and then move on to the next thing. NASA wants to go to the moon and build a new vehicle, and so that's where we're headed.
What else is on the agenda before 2010, aside from getting the space station fully stocked?
Well, the big event comes in October, and that's the one that we're going to be spending a lot of time talking about as time grows near. That will be the final repair mission for the Hubble Space Telescope. And there's a couple of things that are interesting about that. First of all, the Hubble, everybody loves the Hubble and the images it has delivered, and the hope is that they can give it another 10 years of life, which would be wonderful, as well as giving it the capability of being safely deorbited at some point in the distant future. But the other thing that I need to tell you about this is that this will be the first mission post-Columbia that wouldn't be to the International Space Station. There won't be a safe harbor component. So they'll actually have 2 shuttles ready here. In case there's a problem with the one that goes up to Hubble, they'll have a backup ready to go perform a rescue mission if need be.
Wow, fascinating stuff. Miles O'Brien joining us. Many thanks. Discovery is suited up and strapped in. And he's learned a thing or two about the Royal Air Force. Now Britain's Prince William is about to test his sea legs. That's just ahead on World News. Final inspections are underway for the launch of the Space Shuttle Discovery. Liftoff is less than an hour away. Discovery will bring part of a science lab to the International Space Station. A toilet pump is also on board. The station's lone toilet is broken, and the astronauts hope the part will fix it. So right now it's all systems go at Florida's Kennedy Space Center. CNN space correspondent Miles O'Brien is covering the launch and he joins us now. Miles, good to have you back on the show. NASA is describing this latest shuttle mission as one of its most complex. Why?
Well, it's complex because there is a huge part inside the cargo bay of the Space Shuttle Discovery. This is, about the size of a DC-9 airliner. And inside here is a piece of the space station made by the Japanese, weighs 13,000 kilograms, the size of a bus, that will dramatically increase the scientific potential of the International Space Station. And really, a year from now, because this laboratory is there, assuming a lot of other things go right, the space station will move into a much more robust configuration with a 6-member crew instead of 3. It takes 2 people just to run the station, so having only 1 person available for science has been very limiting. Having this laboratory up there with 6 people, 2 of them running the station, 4 of them involved in science, will finally give the 900,000-pound structure its reason for existence, creating scientific advances in the absence of gravity. So Kibo is on board there. The 7-person crew's main mission is to deliver that. They are strapped in and ready. The weather is 90% go here right now, and we are less than an hour away from launch. All systems looking go right now. Of course, you got 1 million parts in here. Anything can happen. We're watching the countdown very closely. Also, a very important part of this mission, which really just came to light over the past few days, the toilet on the space station, as you alluded to, Aisha, has been broken for more than a week now. There's a pump on board there that provides suction to separate liquids out. It hasn't been working properly. The crew swapped out 1 and then 2, and both of those swaps failed. And so they needed a spare part in order to make this toilet work in a fully functional manner. They've come up with a workaround, which is kind of a manual way, which is not a very convenient way to use it, although it does provide some relief for the crew. In any case, that part, weighing 15 kilograms, came from Moscow to Orlando, Florida, was driven here, loaded into the shuttle on Thursday overnight in the wee hours of the morning. Some stuff was taken out to make way for it, stuff that was less priority. And once they get up there and dock on Monday, you can bet that the cosmonauts on the Russian side of the station, where the toilet is, will get right to that business of putting that pump in place. I guess you could say that would be the #1 priority. Now, there is another thing that's kind of interesting. That is a shuttle first, by the way, to have them be a high-flying plumbing supply outfit. Another first on this one is Buzz Lightyear. The Disney people, they do know how to market things. They have a new ride over at Disney World. They're trying to promote it. So they have an educational component to it where Buzz Lightyear will be floating around the space station. They're going to do some experiments which will be fed down to kids so they can learn a little something about zero gravity and so forth. So the toy will be on there, Buzz Lightyear. And of course, Buzz Lightyear of Toy Story fame was named after Buzz Aldrin, 2nd man to walk on the moon. And as part of this whole thing, Disney folks released a little pep talk, I guess pre-flight briefing, with the real Buzz Aldrin talking to the plastic Buzz. Listen to this.
I know where you're going. I've been in space 2 times. I've walked on the moon. Before we can let you go into space, you've got to pass a battery of tests. Are you ready? Anti-gravity test. Fitness test. Centrifuge test. Crash landing test. Rocket test. Congratulations, you're cleared for launch. Just remember one thing. I'm the real Buzz. Piece of cake.
All right, we'll never forget who the real Buzz is here. Anyway, let's get this Buzz ready. We'll get his wings out there. Here we go, Aisha. He's on his way to the space station.
I bet you Buzz Aldrin never thought it would come to this, that he'd be sharing the fame with Buzz Lightyear.
You know, I can tell you, I never would have predicted we'd be talking all week about a broken potty and a plastic toy on the shuttle. Well, this just goes to show you, you never know what's going to happen in the space business.
Let's talk about one more thing. The scientists at NASA have been very, very busy. They've also been keeping tracks on the Mars lander. What's the latest there?
Yeah, interesting stuff on Mars. You know, of course, a week ago this time we were, biting our nails wondering if the Phoenix lander was going to make it to the surface of Mars. On Sunday, they successfully landed, sort of against all odds, a soft landing on Mars near the Martian North Pole. And the reason they wanted to go there was an orbiting spacecraft had detected through some of its sensors the presence of water ice in this Arctic area of the Martian northern climes. They landed there, and water is a big deal because wherever you look on this planet and you find water, you will find life. There is no exception to that we know of. And so the thinking is if you get to water on Mars, liquid or otherwise, you're a little closer to answering some questions about whether life existed there once before, or maybe, just maybe, in an underground aquifer where it's still flowing, maybe exists now. So what they discovered in looking at the pictures there that they've been assessing is they believe in the course of landing on those rockets, they kicked up an ice block. And there's actually a piece of ice that is sitting there on the surface. Now, the bad news is it's out of the reach of their scoop, which is only, after all, about 2.5 meters in length. So that's not good, but if there's one ice block out there, there's a very good chance when they dig down in their range, they might very well find the ice they've been looking at, put it in an oven, cook it, and who knows, maybe they might find some organic compounds, which, of course, are a building block of life as we know it. So that's pretty exciting stuff scientifically. We're going to be watching that one very closely. Could be some really fundamentally big news that comes out of this mission. Scientists don't like to hype it, but this could be a big deal. Aisha?
It sure could, and we'll have you monitoring it all for us and breaking it down. I'm Miles O'Brien. Many thanks.
OTC?
OTC go.
TBC? TBC's go. TTC? TTC is go. LPS? LPS go. Houston flight? Houston flight is go. Milo?
Milo go.
STM? STM is go. Safety console?
Safety consoles go.
SPE? SPE is go. LRD? LRD is go. SRO? SRO is go. You have range clear to launch. And CDR? CDR is go. And Launch Director NTD, our launch team is ready to proceed at this time.
Okay, cover that, Jeff, thanks. Chief Processing Engineer, verify no constraints to launch.
Mike, the engineering team is ready to go.
Okay, thank you, Charlie. KC Safety Mission Assurance.
KC and Safety Mission Assurance is go, Mike.
Thank you, Mark. Payload Launch Manager.
Space Station team is ready to go, Mike.
Good, thanks, Bill. Range weather.
Weather has no constraints for launch.
Very good, Kathy. And Ops Manager.
Let's see, Launch Director, Ops Manager on 212. Mike, the MMT is not working any issues. You are go to launch.
Okay, thanks, Leroy. Discovery Launch Director.
Go ahead.
Okay, Mark, it's a gorgeous day to launch, so on behalf of the KSC launch and processing teams, I'd like to wish you good luck, Godspeed, as you deliver the next piece of Kibo to the International Space Station.
Hey, thanks, Jeff. You're right, we're going to deliver Kibo or Hope to the space station. And while we all tend to live for today, the discovery from Kibo will certainly offer hope for tomorrow. Minasan arigato, ite kimasu. Now stand by for the greatest show on Earth.
Thank you, sir. NTD, with that, you are clear to launch Discovery.
Copy that. Thank you, sir.
TLS is go for orbiter access arm retract.
Discovery OTC, best of luck delivering the GEM module to the International Space Station.
Discovery copies. Thank you, Teresa.
The go has been given to retract the orbiter access arm. This is the walkway that the crew uses to get inside and outside of Discovery. And if the need arose, we could move it back into position within a few seconds.
CLT, perform AP pre-start.
And that's in work.
Final test of the flight control surfaces being done with a pre-programmed pattern of movements designed to verify the engines and other flight surfaces are ready. It includes moving the 3-min engines, and that's how Discovery steers its way in orbit. Top of the external fuel tank, known as the beanie cap, being removed at this time.
CLT, cluster warning memory clear is complete with no unexpected errors.
Copy. Discovery, close and lock your visors and initiate O2 flow.
Discovery and work.
TLS is go for ET LH2 pressurization.
Stop. Destination, the International Space Station.
Discovery and work.
The most complex missions to date. It is a cloudless day. There are no delays to this particular mission, and just an hour or so. You can imagine the adrenaline flowing in the 7 astronauts, 1 Japanese and 6 American, as they were strapped in, and workers closed the hatch to the space shuttle and moved away. Now, this is a truly international mission. Scores of Japanese and other dignitaries were at Kennedy Space Center to witness the shuttle carrying up this main segment of the Japanese Kibo Research Station to the International Space.
It's quite a magical two minutes of riding uphill in first stage.
All right, we are inside 1 minute now. I just want to tell you the voices you're going to be hearing as this Discovery makes its way toward space. Adler Butel is a public affairs officer here in the Launch Control Center. You'll hear him first, and then it'll switch over to Houston. Rob Navius, public affairs officer there, will be providing us some key data points as this all unfolds. As we reach the point of 30 seconds, Doug, things start happening very quickly and automatically now.
Absolutely. At T-minus 31 seconds, control is handed over to the shuttle onboard computers. And we're at that point right now, and the shuttle is on its way. Now, there is systems in place to, if we need to do a pad abort or abort the launch, that can be done, but the shuttle is in complete control now.
All right, let's listen now.
10 seconds. We have go for main engine start. 7, 6, 5, 4, 3, 2, 1. Booster ignition and liftoff of Shuttle Discovery. Combate Kudasai. Best of luck to the International Space Station's newest laboratory.
Houston, Discovery, roll program.
Roger, roll, Discovery. Houston now controlling the flight of Discovery, a man-made rising sun on behalf of Japan. Discovery on the proper alignment, heads down, wings level for the 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 36 seconds into the flight, the 3 liquid fuel main engines now throttling back to 72% of rated performance, going in the bucket, reducing the stress on the shuttle as it goes supersonic. Discovery already 5 miles in altitude, 8.5 miles downrange, traveling almost 1,000 miles an hour. Discovery Houston, go at throttle up.
Roger, go at throttle up.
Throttle up call acknowledged by Commander Mark Kelly, joined on the flight deck by pilot Ken Ham, flight engineer Ron Guerin, and mission specialist Karen Nyberg. Down on the middeck are Mike Fossum, Aki Hoshide, and Greg Shamatov, heading for a half year on the International Space Station.
And this is a key part of the whole situation here, Doug, where you've got those twin solid rocket boosters still attached. Once you light those solid rocket boosters, there's no turning them off.
That's exactly right, Miles. It's solid fuel. You can't throttle these things.
1 minute,
And so you essentially are along for the ride when you're on these boosters. And so there is a collective sigh of relief at about 2 minutes and 5 seconds when we get off the boosters. We're waiting the moment now. And when that happens, there's a collective sigh of relief, although we still have 6 more minutes to ride to space.
And the amount of acceleration there is really hard to comprehend when you consider going from that launch pad 0 to 17,500 miles an hour. Do you feel that acceleration, though?
Absolutely.
You do?
Absolutely, you do. You feel it. It's a
there goes the solid rocket boosters. That's a good sign right there.
That's a very good sign now. And actually, this occurs at about 150,000 feet at Mach 5. Very little drag up there, and now you can feel the full force, full thrust of those shuttle main engines. It really presses you back in your seat at 3 times gravity, essentially 3 of yourself sitting on your chest. Now,
is it hard to breathe?
It is. Is it a little bit difficult to breathe? It is a little bit mechanical. It's equally as hard to reach out and actuate a switch or something if you needed to do that. So if the crew, it sounds like we have a very, very clean ascent. The crew is probably checking their reachability of different switches in case they need to actuate something. And so there's a pretty good force on the crew now as they push back in their seats.
Now we're looking at this shot, which is the external fuel tank camera looking back at the orbiter. And of course, you see the curvature of the Earth, the darkness of space. That camera, while it's wonderful for us to go along for the ride, is there for really some engineering and safety reasons. They want to make sure that big pieces of that foam, which insulates the external fuel tank, don't fall off, causing damage to those thermal protection tiles on the belly of the shuttle. I've not seen anything big fall off there. This will be something they'll be pouring over, though, for the hours and days to come.
Absolutely, Miles. And you can also see in that view, you can see the leading edge of the wings of the shuttle as well, which is reinforced carbon-carbon, that we also want to take a look to see if there's anything that impacts those leading edge of those wings. This looks very clean, and it looks like a very, very clean ride to orbit.
All right, we're about 3 minutes in now, and 3 minutes, 40 seconds or so, and as they go up, as they build altitude, and as they build speed, their options, if something goes wrong, increase, correct?
Absolutely.
They can, instead of having to come back here for an emergency landing, they start thinking about possibly an emergency landing, say, in Europe.
Absolutely. We have what's called a TAL site, is a transatlantic landing site, and we have several of those in Europe that we can abort to a landing site across the pond.
Of course, it's never happened. There's one abort to orbit years ago, as I recall, when an engine shut down prematurely. They ended up doing the mission. But what you're thinking about the entire time as you go up to space is what happens if something goes wrong. Right?
Absolutely, absolutely. You're totally in the training mode at that point, and you're reviewing all your procedures. You're looking at what the vehicle is telling you on your screens and on your gauges and dials, and the crew is decisively engaged in what's going on and what the vehicle is telling them.
And our apologies as the helicopter, which provides security here, lands as it does at this time in every case. So far, I've not heard a single thing, any calls from the ground or to the crew that would indicate anything that's going wrong here.
Absolutely. Sounds perfectly clean, Miles. And that's good news.
And as it goes up, as you get to this point, it's a much smoother ride when you've lost those solid rocket boosters. But the G-forces, this is when they build up and you really start to feel it,
You can really feel the power of those shuttle main engines. Each one of those engines produces about 13 million horsepower and a pretty good amount of thrust, so about 375,000 pounds of thrust each. And so you essentially have little drag at this altitude, and so you can feel the full power of those engines pressing you back in your seat.
All right. Now, what they said there was press to ATO. Decipher that. What does that mean?
It's essentially it's an abort boundary where we know that if we lose an engine, we can abort to orbit. ATO is abort to orbit. So if we lose an engine, all 3 shuttle main engines are functioning properly. But if we lost an engine, we can make it to orbit.
So that's
Fähre angedockt, die muss doch auch eine Toilette haben, oder?
Man hat ja immer, zum Notfall hat man immer die Sojus-Kapsel anhängen. Das heißt, jetzt sehen wir übrigens, wie die Sonne unter der Shuttle scheint. Es dauert nicht mehr lange. In 1,5 Minuten wird sich der Shuttle übrigens vom externen Tank trennen. Ja, also nochmal zur Sojus-Kapsel. Ja, dort gibt es auch eine kleine Toilette, aber die ist ganz klein. Tatsächlich besteht die nur aus so einer Art ich möchte mal sagen, Theatertäschchen. Das, was die Damen so ins Theater tragen, so weiße Täschchen, die nennen die Amerikaner Apollo-Bags. Da kann man reinmachen, da zieht man oben das Bändchen zu und dann hat man das weg und tut es in den Nassabfall. Es ist also keine richtige Toilette, es kommt noch aus den Apollo-Zeiten und damit kann man natürlich nicht allzu lange auf die Toilette gehen oder seinen Abfall beseitigen. Deswegen braucht man schon eigentlich langfristig eine gute Toilette. Und es gibt eine Regel bei der NASA, die besagt, wenn die Shuttle-Toilette oder die ISS-Toilette sehr lange Zeit nicht benutzbar ist, muss der Shuttle wieder zurück zur Erde. Das ist also ein sehr hartes Kriterium.
Alles klar. Was passiert eigentlich mit dem Rest, der aus diesen Toiletten rauskommt? Wird der einfach in den Weltraum geworfen? Gibt es Weltraummüll?
Gute Frage. Also das, was der Shuttle an Toilette hat, das bringt es auch wieder zurück. Das, was die ISS als Toilettenabfall hat, das wird in das Versorgungsschiff zurückgetan. Das Versorgungsschiff kommt ja alle paar Monate hoch. Die Abfälle werden ins Versorgungsschiff reingetan und das verglüht dann in der Atmosphäre. Insofern hat man sozusagen einen abfallfreien Rückstand.
Herr Walter, ich muss mich bei Ihnen bedanken, beziehungsweise ich bedanke mich sehr herzlich bei Ihnen, aber ich muss diese Sendung jetzt beenden. Wir machen weiter im Programm hier bei N24. Der Start ist ja wunderbar verlaufen. Vielen Dank, Herr Walter, und schönen Abend noch.
Das wünsche ich Ihnen auch. Auf Wiederhören.
Danke, Dankeschön.
Pressure to 0G. What's that?
Discovery
I know that
passing
some
23,000
astronauts
feet
get
per
sick,
second
and you
at
can
the 8-minute
understand
mark
why.
into the
That's
flight.
a difficult transition.
Flawless ascent so far for the order.
Some people adapt very, very quickly. Some people have delayed reaction to the introduction to 0G.
Standing by for main engine cutoff. That'll
here.
be followed a few seconds later by the separation of the external fuel tank.
And you'll hear a MECO call, which stands for main engine cutoff, and you'll hear MECO confirmed.
What is that flaming we're seeing around there? What does that mean?
Booster officer confirms
actually
main engine cutoff, standing by for external tank
expansion of the gases coming out of the shuttle main engines. We're now essentially in space in a complete vacuum, and so that expansion is behaves quite a bit differently than here on Earth, or here in our atmosphere.
And there you watch that separation, that wonderful. It's almost a ghostly image as the orbiter and the tank separate.
It is. You'll see jets firing on the shuttle to move it away from the external tank, and then the shuttle will actually do a 180-degree flip onto its back, and so you could see this external tank out the upper windows.
What kind of a sight was that to see that? Could you believe where you were?
It was amazing. It was amazing. There's a lot of, you have to keep focused on your work because there's a lot of wow factor. That's just an amazing sight.
All right, what you just witnessed was textbook getting to space in a space shuttle. 8.5 minutes of one wild ride. Amazing that it all comes together, really, when you think about all the things that have to go right to have what happened just happen.
Absolutely, sir. Absolutely.
All right.
Tremendous experience.
A word about this mission, putting on this Kibo laboratory. Significant milestone for the space station. I know you'd like to go up there someday and work on the space station. Having that laboratory means a lot for the station. Actually gives it some scientific potential that it doesn't have.
Absolutely, absolutely. It really is a huge milestone for us and for our international partners. It really completes the laboratory complex that we intended to do all of our space. Now, we still have later this year a solar array to go up to produce more power for these laboratories, but in a large sense, it brings some completion to the building of our laboratory complex.
All right, and we're just along the way. It's hard for us to see sometimes, but I'm just being told there was a piece of foam which came off at the 3-minute and 30-second mark. Now that's pretty late in the game, and that's a period of time when there's a lot less aerodynamic pressure on that foam. Less of a concern there?
Less of a concern at that altitude for sure, because of just what you said, Miles, the drag in that area and atmospheric pressure in that area, so your relative velocity of a piece of foam would be quite a bit less at that altitude.
That big piece of foam which came off of Columbia back in January of 2002 happened much sooner in the ride up to space, where the air was much thicker, and as a result, the change in speed was such that it caused a bigger impact.
Yes, sir. That's exactly right.
All right. Well, this is going to be a 2-week mission. The crew is just getting do you call them space legs? I don't know. What do you call it?
Space legs. We call it that, and space tummy. Sometimes we refer to it, but everyone reacts differently. The body is an amazing machine, and sometimes it takes a day or two, or just a couple of hours to adapt. But,
5 rookies on board here. There's a lot of wild cards as to who's going to be ill and not now. And hopefully, statistically, only a few of them are.
A lot of wild cards there, and of course, you try to some try to power it out, but we all react differently to zero G, but the body adapts very, very quickly, and within a few hours, you feel like you've lived there your whole life.
All right, picture-perfect launch here at the Kennedy Space Center. Wolf, the Shuttle Discovery, now traveling 17,000.
All right, then we're going to break away from those scenes from the Kennedy Space Center. You have been listening to our space correspondent Miles O'Brien, who was joined by Doug Wheelock, an astronaut. They watched the scenes as Space Shuttle Discovery launched into space. As Miles was saying, it was a picture-perfect takeoff. We did hear Miles say, though, just at around the 3-minute mark, a piece of foam fell off the shuttle. We don't know the implications for that. We'll continue to monitor that. But as Miles was saying, the shuttle on its way into space, a 14-day mission. It will spend time with the International Space Station, and we'll continue to follow that story for you. Moving.
Coming up on go for auto sequence start. The computers on board Discovery control the spacecraft.
TLS go for auto sequence start. 25.
T-minus 25 seconds and counting.
20.
T-minus 15 seconds and counting. 10 seconds. We have go for main engine start. 7, 6, 5, 4, 3, 2, 1. Booster ignition and liftoff of Shuttle Discovery. Combate Kudasai. Best of luck to the International Space Station's newest laboratory.
Houston and Discovery, roll program.
Roger, roll, Discovery. Houston now controlling the flight of Discovery, a man-made rising sun on behalf of Japan. Discovery on the proper alignment, heads down, wings level for the 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. 36 seconds into the flight, the 3 liquid fuel main engines now throttling back to 72% of rated performance, going in the bucket, reducing the stress on the shuttle as it goes supersonic. Discovery already 5 miles in altitude, 8.5 miles downrange, traveling almost 1,000 miles an hour.
Discovery Houston, go with throttle up.
Roger, throttle up.
Throttle up call acknowledged by Commander Mark Kelly, joined on the flight deck by pilot Ken Ham, flight engineer Ron Guerin, and mission specialist Karen Nyberg. Down on the middeck are Mike Fossum, Aki Hoshide, and Greg Shamatov, heading for a half year on the International Space Station. One minute 45 seconds into the flight. Discovery 22 miles in altitude, 23 miles downrange, standing by for solid rocket booster separation.
Copy staging.
Booster officer confirms staging, a good solid rocket booster separation. Guidance now converging. The onboard computer steering the shuttle for the on-ramp to the highway for the International Space Station. Discovery 37 miles in altitude, 50 miles downrange, traveling 3,200 miles an hour. The orbital maneuvering system engines have ignited, providing Discovery with a burst of power for the next 2 minutes 15 seconds.
Roger, 2-engine Maroon.
That call from Mark Kelly, the first of a series of performance calls in the event of the loss of a main engine. However, all three main engines continue to perform normally, along with the auxiliary power units and the three power-producing fuel cells. Discovery flying on the singular power of its three liquid fuel main engines, draining a half a ton of fuel per second from the large fuel tank. Discovery 52 miles in altitude, 100 miles downrange, 3.5 minutes into the flight. We're coming up on the point of negative return, where the shuttle would be too far downrange, too high in altitude to return to the launch site in the event of an engine failure. All three main engines continue to function normally, however. 3 minutes, 47 seconds into the flight. Discovery flying straight and true, speeding toward a date with the International Space Station on Monday.
Discovery Houston, negative return.
Roger, negative return.
All of Discovery's systems in great shape. 4 minutes, 15 seconds into the flight. Discovery 62 miles in altitude, picking up speed, 170 miles downrange, traveling 5,300 miles an hour. The Environmental Systems Officer reports the activation of the flash evaporator system, providing cooling for Discovery's avionics and other systems until the time that the payload bay doors are open an hour and a half into the flight. 4 minutes, 40 seconds into the mission. All the main engines right down the money, in good shape, good performance, good auxiliary power units, good fuel cells. Discovery traveling 6,000 miles an hour, 66 miles in altitude, 230 miles downrange from the Kennedy Space Center. Five minutes into the flight, 3.5 minutes of powered flight remaining. Very quiet here in the flight control room.
Discovery Houston, press to ATO, select Istris.
Roger, press to ATO, we'll select Istris.
That call acknowledged by Commander Mark Kelly, indicating that in the event of a loss of a main engine, we could still make our abort to orbit targets. However, all three main engines continue to function normally. The orbiter will soon begin to roll to a heads-up position. Now beginning that roll to heads-up. The main engine's now swiveling. The shuttle rolling to its position above the fuel tank, gaining more favorable communications to the tracking and data relay satellite system as it heads uphill. 6 minutes, 15 seconds into the flight. Discovery traveling almost 10,000 miles an hour, 397 miles downrange from the Kennedy Space Center.
Istris 104. Your shutdown plan is nominal, and your go for the plus X, go for the pitch.
Copy that, Terry. Copy the boundary. Nominal shutdown plan. Go for the plus X, go for the pitch.
Good readback, and you are pressed to MECO.
Roger, press to MECO.
Press to main engine cutoff call by Commander Mark Kelly, indicating should we lose a main engine, we can still make our nominal main engine cutoff targets. However, all three main engines hang in perfectly, as well as the auxiliary power units and the fuel cells at the 7-minute mark into the flight. Discovery now 515 miles downrange from the Kennedy Space Center, traveling 11,000 miles an hour. Very soon, the main engines will once again be throttled down to limit the stress on the shuttle and its 7 crew members to that of 3 times the effective gravity.
Houston, single engine press 104.
Roger, single engine press 104.
At the time of main engine cutoff, a little more than a minute from now, Discovery will enter its preliminary orbit at a speed of 5 miles a second. Discovery 615 miles downrange from the Kennedy Space Center, looking great. Engines now throttling back. Less than a minute of powered flight remaining for Discovery. Traveling 14,000 miles an hour, almost 700 miles downrange from the Kennedy Space Center. Discovery passing 23,000 feet per second at the 8-minute mark into the flight. A flawless ascent so far for the orbiter. Standing by for main engine cutoff. That'll be followed a few seconds later by the separation of the external fuel tank.
Copy, Nico.
Booster officer confirms main engine cutoff, standing by for external tank separation. External tank separation confirmed. Discovery now in its preliminary orbit. The centerpiece of Japanese space science, Kibo, completing the first leg of its journey to the International Space Station.
I'm not seeing 1,000 here. Shoot.
This is Mission Control Houston, the first view of the discarded external fuel tank that was jettisoned and separated from the orbiter just moments after main engine cutoff following Discovery's climb to orbit. This video captured by mission specialist Karen Nyberg at the same time that crewmate Mike Fossum was taking digital still pictures of the tank. This while Discovery was a distance of about 1,450 feet away from the tank itself.
I want to swap my...
That white object in the upper left-hand portion of the screen, believed to be a large patch of ice, which is typical once an orbiter reaches its preliminary orbit above the Earth.
Not right now.
Again, this handheld video of the external fuel tank taken by mission specialist Karen Nyberg yesterday out of the aft flight deck window of Discovery, just moments after Discovery had reached its preliminary orbit following its launch at 4:02 p.m. Central Time from the Kennedy Space Center. Again, you're looking at ice, crystals, small sheaths of ice from the orbiter, which is typical following its climb to orbit. Use with the external fuel tank and the Earth below as a backdrop in this handheld video shot by mission specialist Karen Nyberg shortly after Discovery reached orbit yesterday.
Right on the right.
Yeah.
The only thing we're missing is I'm going to go to get rid of my helmet now. Okay, we got the top.
Yeah, the settings on here are making it real bright on the side. It's not good. Now I got it set. Man, I gooned that up.
Okay.
And out of your helmet. Hey, Karen?
Yeah?
When we get a chance, we're still be interested.
Okay.
Yeah, Karen, if you could jump on it now, if you think you got enough video.
All right. Sorry. I'm trying to get this switch. I can't quite reach it. There we go.
I got you. That's fine. I got you foot if you want.
All right. I'm good. Hey, Ron, welcome to space.
We're here. Okay, so Hawk, you got MPS power down, GH2.
Correct, that's all complete.
G bolt the door. Call. It might be in space.
Discovery Houston on 1 for the PC handheld video. Looks like that's done. Thank you for the great imagery.
I don't want to rush you,
right.
But in post-insertion, Houston Discovery.
Copy that. Thanks, Dick.
Yeah, we're through with through page.
Coming up on the 1 hour mark of Discovery's flight since its launch from the Kennedy Space Center at 4:02 p.m. Central Time. That launch was viewed by the crew on board the International Space Station, which Discovery is headed for a docking on Monday afternoon. Commander Sergei Volkov, flight engineer Oleg Kononenko, and flight engineer Garrett Reisman, who is soon to be replaced by Greg Shamatov, who will spend a half year on the complex. You are watching a replay of them watching the launch as it occurred just about an hour ago on a TV feed that was uplinked to the International Space Station, watching off of an onboard laptop computer in the Destiny laboratory of the station. Volkov and Kononenko were launched on a Soyuz spacecraft from the Baikonur Cosmodrome in Kazakhstan on April 8th, arriving on the station April 10th. Reisman was launched aboard the Shuttle Endeavour to the International Space Station back in March on the last mission.
Block 4, post-insertions in work.
Reisman wrapping up 3 months on board the complex. He will be replaced by Greg Shamatov. The swap out of crew members to occur within a few hours after docking on Monday, when Reisman and Shamatov exchange custom-made Soyuz seedliners. That will mark the official end of Reisman's tenure as a station crew member and the official beginning of Shamatov's 6 months on board the station.
Discovery Houston, we've got a beautiful view of Kibo and Texas behind you there. And you are go for orbit ops.
Yeah, Terry, thanks. Copy the great view. It's great to be back in space. And we've got block, I didn't let you know, we had block 7 complete, 18, and block 20 is in work, and block 5 is in work on the middeck.
Okay, copy all. Thanks for the update.
And this was the moment the shuttle launched. It was carrying a huge Japanese laboratory called Kibo, which has been loaded into its cargo bay. And NASA is saying this is one of their most complex missions to date. It'll last for 2 weeks and involve 3 spacewalks and more building work on the International Space Station. Well, our correspondent Andy Gallagher has been following the event in Miami. I spoke to him about the launch.
NASA really couldn't ask for more perfect conditions. As you can see in those pictures there, a perfect blue sky, no weather threatening the shuttle at all. And it is a very complex mission, as you said. That Kibo Space Laboratory, about the size of a school bus. It weighs something like 16 tons and will really put Japan at the forefront of space exploration. They're going to be in space for about 2 weeks, and they'll carry out 3 spacewalks in that time.
It's not the major scientific plans for this mission that have been grabbing all the headlines this week, however. I mean, we know about its other interesting emergency mission.
Yes, indeed. A pump for the toilet on the International Space Station was specially flown to Orlando from Moscow because the toilet on board, the only toilet on board the space station, was broken. It's been broken for several days now. That the astronauts have been having to operate it manually, a 10-minute job, which takes up a great deal of time. So I think they will very much welcome that particular piece of equipment.
Let's just talk about that Kibo section it's taking with it, Andy. I mean, this is an enormous piece of what's going to be a very impressive piece of equipment up there.
That's right, and this is only the second shuttle launch to get all of the parts of the Kibo laboratory up to the International Space Station. They made a mission a few months ago. This is obviously the main part of the laboratory. It's going to be so big it will enable 4 scientists to work inside of it, and will be the biggest single room on the International Space Station. There will be another mission in a few months' time taking up the more components of the Kibo lab, but it really does put Japan to the forefront of space exploration. The Japanese agency say this is an historical moment.
Andy Gallagher there in Florida.
Eight and a half miles downrange, traveling almost 1,000 miles an hour.
Small pieces of foam were seen breaking off as the Discovery lifted off, but NASA officials say they don't pose any danger. Meanwhile, the crew on board the space station were eagerly waiting for the delivery of another piece of vital equipment. For several days now, the orbiting lab's toilet has been broken, forcing the astronauts to operate their loo manually and all in zero gravity. The Discovery will bring a new toilet pump, specially made in Russia. NASA plans a further 2 missions this year with the aim of continuing work on the space station. It has to be finished by 2010, when the shuttle fleet is retired.
For the Japanese, this is an important mission. Once their Kibo lab has been installed, the Japanese Space Agency will be at the forefront of space exploration with the largest single room aboard the space station. But of course, the piece of equipment that's been grabbing all the headlines is that toilet pump. Discovery's crew may get a welcome warmer than normal once they arrive and it's been installed. Andy Gallagher, BBC News, Florida.
Alda report. The Space Shuttle Discovery is streaking toward the International Space Station right now, carrying a new Japanese-built laboratory that's as big as a bus and cost $1 billion. It's also carrying something that the members of the space station crew have been squirming for. It's a 35-pound pump for their broken toilet, and this is no laughing matter. Miles O'Brien was in Florida for the liftoff.
3, 2, 1. Booster ignition and liftoff of Shuttle Discovery.
On a flawless day, it was a flawless countdown for the Space Shuttle Discovery, the 7-member crew making its way to the International Space Station, carrying with it a bus-sized Japanese-built laboratory called Kibo, which is hope in Japanese, which will greatly expand the scientific potential of the International Space Station, laying the groundwork for about a year from now, doubling the crew size from the current 3 to 6. NASA Administrator Mike Griffin says this is what we've all been waiting for on the space station.
The space station is a 900,000-pound ship, more than 900,000 pounds. It's a huge device. It takes a couple of people just to operate it.
During the launch, NASA mission managers and engineers watched very carefully the camera attached to the shuttle's external fuel tank and noticed at least 5 pieces of that insulating foam falling off the fuel tank toward the Space Shuttle orbiter. This, of course, a big concern after the loss of the Space Shuttle Columbia, which lost a piece of its heat shield as a result of foam falling off of it, leading to the loss of that vehicle and crew. As it turns out, the engineers do not appear to be too concerned about it because those pieces of foam fell off at much higher altitude than they did in the case of Columbia, and it is very likely they fell harmlessly in that thin atmosphere. Nevertheless, they'll be going through those pictures very carefully, looking for any potential damage during the course of this 2-week mission. Also an important part of this mission, the 7-member crew carrying on board a 35-pound toilet pump to replace a broken pump on board the International Space Station. The crew there has been dealing with a bulky toilet for more than a week. Replaced the pump, a spare broke, the next spare broke, and this one was airlifted in from Moscow, driven here to Florida, and put on the Discovery at the last minute in order to try to fix the toilet, the one and only toilet, on the International Space Station. The crew has been able to come up with a manual workaround. They do have toilet facilities, but this pump is a very important secondary part of this mission, and perhaps for the crew of the International Space Station, they would consider it the #1 priority. Miles O'Brien, CNN at the Kennedy Space Center, Florida.
And with apologies for those terrible puns that Miles has given to there.
Auch in der Schwerelosigkeit gibt es irdische Probleme. Das Klo der ISS ist verstopft und die Discovery bringt dringend benötigte Ersatzteile.
So groß war wohl noch nie der Druck vor dem Start einer US-Raumfähre zur ISS. Ohne die kleinste Verzögerung hob die Discovery ab, verlor allerdings kurze Zeit später einige Schaumstoffteile von der Isolierung des Haupttreibstofftanks. Ähnliches hatte Sekunden nach dem Start der Raumfähre Challenger 1986 zur Katastrophe geführt. Es ist wohl nicht so schlimm, weil es diesmal außerhalb der Atmosphäre passierte und die Teile nur klein waren. Groß wie ein Bus dagegen das neue japanische Weltraumlabor Kibo an Bord, das größte bisher ins All transportierte Modul. Doch nicht dessen Montage sowie neue Außeneinsätze der Astronauten stehen im Blickpunkt, sondern der Einsatz aller Einsätze, die Reparatur der seit einer Woche defekten ISS-Toilette. Hier unten auf der Erde ist so etwas nicht schwer. Aber da oben ist es, als ob man etwas an der Zimmerdecke repariert. Ohne Schwerkraft fliegt alles herum. Und genau deswegen ist eben auch eine Weltraumtoilette, die alles mit Unterdruck absaugt, was auf der Erde mit Wasser weggespült wird, so wichtig. Ob die defekte Klopumpe, wie bereits vor ihr andere Schrottteile der ISS, als Weltraummüll endet, ist aber noch offen.
Der Internationalen Raumstation muss die vergangene Woche ziemlich unangenehm gewesen sein. Die einzige Toilette der ISS ist kaputt. Doch Rettung naht, denn die US-Raumfähre Discovery ist mit den sehnlichst erwarteten Ersatzteilen gestartet. Schon morgen soll sie an der ISS andocken und Erleichterung bringen. Außerdem haben die 7 Astronauten noch ein tonnenschweres Modul für das japanische Forschungslabor Kibo an Bord.
And a special good morning to you today, Ken. Welcome to your first full day in space.
Well, thanks, Shannon, and I know where that one came from. It's been a long time and some great memories since that song. Thanks, Mom.
This is Mission Control Houston. We're watching video that was being downlinked by the crew of a Discovery of their launch yesterday. This is a camera that was mounted inside the crew cabin. On the left-hand side is pilot Ken Ham. Directly behind him is mission specialist Karen Nyberg. Beside her is mission specialist Ron Guerin, and to the right of the screen is Commander Mark Kelly.
7, 6, 5, 4, 3, 2, 1. Booster ignition and liftoff of Shuttle Discovery. Combate Kudasai. Best of luck to the International Space Station's newest laboratory.
Houston, Discovery, roll program.
Roger, roll, Discovery.
Houston now controlling the flight of Discovery, a man-made rising sun on behalf of Japan. Discovery on the proper alignment, heads down, wings level for the 8.5-minute ride to orbit. 4.5 million pounds of hardware and humans taking aim on the International Space Station. Seconds into the flight, the 3 liquid fuel main engines now throttling back to 72% of rated performance, going in the bucket, reducing the stress on the shuttle as it goes supersonic. Discovery already 5 miles in altitude, 8.5 miles downrange, traveling almost 1,000 miles an hour.
Discovery Houston, go at throttle up.
Roger, go ahead, throttle up.
Throttle up call acknowledged by Commander Mark Kelly, joined on the flight deck by pilot Ken Ham, flight engineer Ron Guerin, and mission specialist Karen Nyberg. Down on the middeck are Mike Fossum, Aki Hoshide, and Greg Shamatoff, heading for a half year on the International Space Station. One minute, 45 seconds into the flight. Discovery 22 miles in altitude, 23 miles downrange, standing by for solid rocket booster separation.
Copy, state.
We've got the ET photo card in the machine here. I'm not sure. I'll let you know which one it's in. It's actually in the KFX, and we'll be sending you the ET handheld video down as soon as the ascent video is complete.
Thank you, Monk.
You're seeing the end of the replay of the ascent flight deck video that was captured by a camera on the flight deck looking aft during Discovery's climb to orbit yesterday. Pilot Ken Ham on the left, behind him Karen Nyberg, Ron Guerin in the middle of your screen. That is Mike Fossum reaching across Guerin. Fossum floated up from the middeck where he was seated along with Aki Hoshide and Greg Shamatoff for launch yesterday. This was in the post-main engine cutoff time frame. You see Karen Nyberg getting out of her seat. She operated a video camera, and Mike Fossum operated a digital still camera to take high-resolution pictures of the shuttle's external tank from a distance of about 1,450 feet as it floated away from the shuttle Discovery following a maneuver by the orbiter following external tank separation. The reference that Kelly made a moment ago was that the card containing the photos of the external tank that Fossum took is going to be downlinked for imagery analysis here on the ground a short time from now. And in the next few minutes, we should be seeing, as soon as this video is over with, the video of the external tank that was captured by Karen Nyberg using a video camera that will be downlinked a short time from now. Again, all of that is part of the archive of imagery that will be analyzed by mission managers in determining whether or not any debris struck the orbiter during its climb to orbit. It is not believed to be the case. Any debris that apparently was liberated during the 8.5-minute ride to orbit was so after Discovery had reached the point of its ascent where it was out of the discernible traces of Earth's atmosphere, out of the critical area of debris transport capability. And so all of the imagery analysis will begin in earnest today, along with much of the imagery that was captured by cameras down at the Kennedy Space Center and airborne during Discovery's climb to orbit. That white object in the upper left-hand portion of the screen, believed to be a large patch of ice, which is typical once an orbiter reaches its preliminary orbit above the Earth.
Not right now.
Again, this handheld video of the external fuel tank taken by mission specialist Karen Nyberg yesterday out of the aft flight deck window of Discovery, just moments after Discovery had reached its preliminary orbit following its launch at 4:02 p.m. Central Time from the Kennedy Space Center.
Ron, welcome to space.
You guys are here. Okay, so Hawk, you got MPS power down, GH2. Correct, that's all complete. Umbilical door. Call. Might be in spring.
Discovery Houston on 1 for the ET handheld video. Looks like that's done. Thank you for the great imagery.
I don't want to rush you, but in post-insertion, Houston Discovery.
Copy that. Thanks, Dick.
This video shot yesterday, just moments after the orbiter reached its preliminary destination in orbit in pursuit of the International Space Station.
Hey, Mike.
Yeah.
Peering down into the middeck, Mike Fossum, as he began to emerge up onto the flight deck to join Karen Nyberg at the aft flight deck for the external tank video. There's Aki Hoshide, the Japan Aerospace Exploration Agency astronaut, in his first moments of weightlessness.
Discovery complete with post-insertion blocks 2 and 3, and block 1 is in work.
Okay, we copy that, Mark. We just had to really hand over and...
Copy the freeze dry will be 3 and dual G.
A look at Greg Shamatov, who tomorrow will join Expedition 17, and his commander Sergei Volkov and flight engineer Oleg Kononenko Karen Nyberg getting her first drink in space down in the middeck. Shamatov stowing gear down in the middeck following his arrival on orbit to begin a half year in space.
There you go. Yeah,
You gotta hook it up?
Yeah. Did you just drop this thing and rewrite it?
Hoshide working a moment ago to tie down the escape pole down in the middeck of the orbiter, which would have been used in the event of a bailout requirement during the orbiter's powered flight. Flight engineer Ron Garan, who was in the center seat of Discovery right behind Commander Mark Kelly and pilot Ken Ham for Discovery's 8.5-minute ride to orbit. And another view, of course, of Mike Fossum. Fossum and Garan, the two spacewalkers for this mission. Later today, will be joined by Shamatov in checking out their extravehicular mobility units, or U.S. spacesuits, that they will wear on the first of their 3 excursions outside the Quest airlock at the International Space Station on Tuesday.
Hey, Augie. Hey, Mike.
This is the bag room.
Yeah, it's a bag room, all right.
And you're the bag lady.
Okay. Gotta find paper.
Oh yeah, they wanted us, they gave us a time to download that if you wanted to.
I wrote it the whole time. 5:30 something.
Look at that amazing hair. That's cool. Hey, Ron.
Hey. 5 minutes ago. But do we have the tape?
It's, I don't know what the V10 went. It does hockey. It might be one of these.
Hey, Mark. With it. Yes. Mark, are you and Hawk sleeping up there? Yeah. Okay, we'll find your bag. Hey, Yaki? Yeah. The V10 that you brought down, was the tape still in it?
Which one?
V10. The flight deck V10.
Karen, saddlebag.
Yeah, it's up there on the port side.
Oh, here it is. Is this it? So this tape that was in here, it'll be going.
Yeah.
So this guy. Slip one of these little ones in the car. Hey, Hop? Yeah. Have you ever slid a little tape in there before?
Yeah, I think I have. It should just fit right in there.
Doesn't feel right. Oh, there it goes. Now we just one. Okay, this was doesn't look like any of this was used. Any idea what part of the world that is?
Trying to figure that out.
Oh, we did it.
Alright, what was the deal?
No, he's rebooting it 3 times. Well, I mean, looking to close the program 3 times.
So Ron, this was a deal big world.
That's Australia. Yes.
The one that was this one. Okay, so they have this line. I'm gonna take a little bit of dock.
Yes, that's Australia.
Hey, Mark, you're on camera here.
Eat up.
Don't play with scissors.
Eat up, Ronnie.
And poke somebody in the eye.
Video shot yesterday by the crew of the Shuttle Discovery shortly after reaching orbit. In this view, Commander Mark Kelly on the left, Mission Specialist Ron Guerin having their first meal in orbit. Candid shots of the crew as it stowed away equipment and began the process of getting acclimated for their 2 weeks of spaceflight. That will be highlighted tomorrow with the docking to the International Space Station at 12:54 p.m. Central Time. Flying over Tierra del Fuego, the Shuttle Discovery with the 50-foot-long robotic arm in motion under the controls of Karen Nyberg and Ken Ham at the aft flight deck of the orbiter, running through a series of systems checks prior to the start of the use of that arm for a limited inspection of Discovery's thermal protection system via the end effector camera at the very tip of the 50-foot-long robotic arm. You can see at the very top of your screen the elbow camera on the shuttle robotic arm. That is not in play today. It is being restrained, basically held in place with a series of restraint straps to prevent any contact that would have incurred with the large Kibo module in the payload bay. Those straps will be released at the beginning of the first spacewalk by Mike Fossum and Ron Guerin on Tuesday, before the arm accepts a handoff of the orbiter boom sensor system from the station robotic arm that will first grapple the OBSS, which is currently attached to a bracket on the S1 or starboard 1 truss of the International Space Station. This is Mission Control Houston, 19 hours, 40 minutes into the flight of Discovery. As the orbiter trailing the International Space Station approach the west coast of Africa over the Atlantic Ocean, the partial survey being conducted by the shuttle's robotic arm and its end effector camera now has moved across to the port wing. Again, the reach and clearances only enable a portion of the survey to be conducted to look at the upper surfaces of the port wing, as was the case for the starboard wing a short time ago. The survey will continue for about another 45 minutes to an hour, and that will be it for today, as the crew then will settle down into a survey of the payload bay and a midday meal before pressing into the second half of its workday in preparation for its arrival at the International Space Station Monday afternoon.
There's Mission Specialist Karen Nyberg in the video taken earlier while she was controlling the shuttle's robotic arm, looking inside the shuttle's window.
Houston Discovery for rendezvous tools checkout.
Karen, go ahead for rendezvous tools checkout.
Yeah, I'd like to pick up in that procedure if you agree, and just wanted to make sure that we had a target stick vector on board.
We do have the target stick vector on board, and you can proceed.
Thank you.
Another view inside the shuttle's payload bay from earlier. This one on the left, moving towards the top of the screen. You can see the Kibo laboratory and its own robotic arm.
And Discovery, thank you. We're seeing the video.
Kick him back.
Hey, Karen.
Ronnie, what are you up to?
Oh, we're getting the EMUs ready to go.
Cool.
So we can take them right over and put them to work.
Picture in my head. Half my head. Well, we could swap the lens out. I was thinking for Earth ops.
Yeah.
But probably don't.
Hey, Hawk, what are you doing over there?
I'm doing an interconnect return. Keep looking for yours. Somebody else.
Hey, Ronnie, Mike. Hey. What are you cooking?
Origin for food.
Oh, no.
I'm going to have some strawberries and some cream spinach. Yum, yum.
Looking for cookies. What's that, Ronnie?
I'm looking for cookies.
Cookies. Daz, what do you got there?
Giant duck.
Giant duck.
I think it's an anaconda.
It's an anaconda.
This is the biting end. Watch out. I'm going to take this end. We want to run this thing up to the through, ideally. Over there to the bulkhead. And then straight forward. There he is.
Short rice cookies?
This is Mission Control Houston. You're watching a video that was acquired by the crew aboard Discovery on Sunday and is being downlinked, essentially crew choice highlights of Sunday's activities, including the use of the shuttle's robotic arm and its end effector camera during the survey of the upper surfaces of the starboard and port wings of the shuttle that took place yesterday. Again, a compilation of crew choice highlights that was put together on Sunday during their Flight Day 2 activities. The crew in the early stages of its rendezvous for docking to the International Space Station, taking a few minutes out to downlink this prior to the time that the KU system will be needed for rendezvous activities.
For the GAO of that.
You've got to put an orange shirt on.
I need to put my favorite Aggie shirt on.
So what do we need, Ted? 4 bag A? G.
Okay, man, we've got a camera card here that has stuff to download on. Okay. You already downloaded one, right?
That was the STS.
Yep. I put the 400 millimeter on there.
All right, should be dumping.
And that,
This is Mission Control Houston. Just a reminder, while you continue to watch the crew's highlight video from yesterday's activities being downlinked by them from Discovery, we're just 3 minutes out from the firing of the right orbital maneuvering system engine for 10 seconds in the next rendezvous maneuver called the NC-4 burn, a course correction burn to fine-tune and further refine Discovery's path for docking to the International Space Station.
We were trying to invent a space dance upstairs before. Say hello, Ronnie. Taz, Mikey, say hello.
Hey. Hello.
This one's going down to the ground, so say like you mean it, man.
Okay. Hey, we're dadgum glad to be here.
That's right. Woohoo! And you didn't even hit your head! Spectacular!
Then I washed it. I washed it and it started going by itself.
Little jamming on the flight deck. Hey, Mark, this one's going down to the ground tonight, so say hi. All right, where are we?
We're about to cross over Baja.
Oh, cool.
And then we'll go up over...
we'll see
We see a good config for the bend.
I don't know how this camera's going to pick that up. No sign of land yet. There's a big old thunderstorm. Probably some ship stuck under there right now. Wishing he wasn't there.
This is Mission Control Houston. As we continue to watch the crew's highlights of activities performed yesterday, we're just seconds away from the NC-4 rendezvous burn. So we'll follow that along while we watch the video simultaneously. The NC-4 burn is underway.
Discovery Houston, good burn, no further trim required.
Discovery copies.
Good morning, Discovery, and a special good morning to you today, Greg.
Good morning, Sharon. Good morning. Good morning, everyone. It's really nice to hear that song. That's a song from a friend of mine, a good friend and jazz musician, Jose Serrano. And if you have to be away from home, this is certainly one of the best places you could possibly be. We're having a great time up here. We had a great time yesterday, and today's going to be even more exciting as we get to see the space station as we approach and dock. So we're really looking forward to today. Good morning to everybody in Mission Control and all the control centers around the world. It's a big day today.
And Discovery, thank you. We're seeing the video.
Kick him back.
Hey, Karen.
This is Mission Control Houston. You're watching a video that was acquired by the crew aboard Discovery on Sunday and is being downlinked, essentially crew choice highlights of Sunday's activities.
Ronnie, what are you up to?
Oh, we're getting the EMUs ready to go. Cool. So we can take them right over and put them to work. Okay. Picture in my head. Half my head. Well, we could swap the lens out. I was thinking for Earth obs.
Yeah.
But probably don't.
Hey, Hawk, what are you doing over there?
I'm doing an interconnect return.
Hey, Ronnie, Mike.
Hey.
What are you cooking?
Foraging for food.
Oh, no.
I'm going to have some strawberries and some cream spinach. Yum, yum.
Looking for cookies.
What's that, Ronnie?
I'm looking for cookies.
Cookies. Daz, what do you got there?
Giant duck.
Giant duck.
It's an anaconda.
It's an anaconda.
This is the biting end. Watch out. I'm going to take this end. We want to run this thing up to the roof, ideally. Over there to the bulkhead. Straight forward. So you put the tube back. There he is.
Again, a compilation of crew choice highlights that was put together on Sunday during their Flight Day 2 activities. The crew in the early stages of its rendezvous for docking to the International Space Station, taking a few minutes out to downlink this prior to the time that the KU system will be needed for rendezvous activities.
Ronnie? Taz, Mikey, say hello.
Hey. Hello.
This one's going down to the ground, so say like you mean it, man.
Okay. Hey, we're dadgum glad to be here.
That's right. Woohoo! And you didn't even hit your head! Spectacular!
Then I washed it. Tied it up, and then I washed it, and it started going by itself.
Little jamming on the flight deck. Hey, Mark, this one's going down to the ground tonight, so say hi. All right, where are we?
We're about to cross over Baja.
Oh, cool.
And then we'll go up over...
We'll see, we'll see Cabo shortly. I don't know how this camera's going to pick that up. No sign of land yet. There's a big old thunderstorm. Probably some ship stuck under there right now. Wishing he wasn't there.
And now you're live on the flight deck of Discovery as Commander Mark Kelly, seconds away now from the small firing of the reaction control system jets and the NCC burn, the course correction burn, that will set the stage for the larger terminal initiation burn coming up just 58 minutes from now. Burn underway.
Discovery Houston, good burn.
Copy, good burn.
This view through the sequential still video system on the shuttle's S-band communication system. That dot at the top of the picture, the International Space Station, as Discovery continues its approach, currently closing at a rate of about 9 feet per second.
Station Discovery, com check. Discovery, this is Station. We have you loud and clear on the big loop. We've got you loud and clear as well, Garrett. We'll be there about an hour and 45 or so, and really looking forward to seeing you guys. Oh, you have no idea how much we're looking forward to seeing you too, and we got a good tally on you at the docking compartment windows. Looking good.
This first view from cameras on the International Space Station of the Shuttle Discovery, now just 3,800 feet away from the complex. Serenely sailing over the South Pacific, the Shuttle Discovery at an altitude of 210 miles, now 2,800 feet away from the International Space Station. A good view now of the Kibo Science Laboratory, 37.5 feet long, 14.5 feet wide, occupying virtually the entire payload bay. This view now of the International Space Station from the centerline camera mounted in the orbiter docking system, the docking mechanism at the forward end of Discovery's payload bay right behind the aft bulkhead and the crew cabin. This will be the same view that Commander Mark Kelly will see during his final approach for docking using a television monitor on the aft flight deck near where he will be flying the orbiter, and its final approach for link up to the forward docking port on the Harmony module of the complex. You can see the large Kibo module in the payload bay of Discovery at the very top of Kibo. That circular apparatus is the common berthing mechanism to which the Japanese logistics module that is currently affixed to the top of the Harmony module will be attached to. The Japanese logistics module that was delivered to the station and temporarily parked on top of Harmony on the STS-124 mission will be removed on flight day 7 and relocated to the top of Kibo in that circular common berthing mechanism that you're looking at. Scintillating view of Discovery, South America in the background, 210 miles below.
And station from Discovery, initiating RPM 3, 2, 1, mark.
The rendezvous pitch maneuver is underway. Ken Ham is choreographing this while Commander Mark Kelly is executing the rendezvous pitch maneuver. Ham will be cueing the station crew momentarily to start photography.
Get ready for Gecko. Да, готов. 2 минуты. Да нет, мы просто быстро фотографируем, Гарри. Yeah, as soon as you see the titles. Okay, I think we should start. Да. And 2, go. Start photos. Start photos. Start photos. Second remain. Second remain. 10 seconds remain. 5. Rest. And photos.
Commander Mark Kelly now will begin the maneuver called TORVA. That's an acronym for Twice Orbital Rate V-bar Approach. Basically, in layman's terms, putting Discovery on a course that will take it away from the radial vector directly underneath the station and put it 310 feet in front of the International Space Station along the direction of travel known as the V-bar or the velocity vector. In the International Space Station Flight Control Room, lead Space Station Flight Director Annette Hasbrook is ready to poll her team to get a go, no-go for docking. The same will take place here in the Shuttle Flight Control Room by lead Shuttle Flight Director Matt Abbott a short time from now.
And Houston in station from Discovery at 160 feet, HHL matches TCS.
Houston copies.
Karen, I'm going to do a Y pulse to the left.
I agree with that.
That'll pick us up a little bit.
You're going to arm it and disarm it. Okay. Okay. But the important thing is the disarm. Exactly.
Discovery now 137 feet away.
A few minutes to go till step 3, final approach.
That's right, approximately.
So Karen, I do see yourselves we're a little right, so that -2 is right.
Yep.
We're coming back. We got a little, we're kind of rising above here. I'm going to put in another up.
Our dot's going to be dead on.
Sure.
As Discovery closes to within 100 feet of the International Space Station inside the Destiny Laboratory, Garrett Reisman completing preparations for the arrival of the 7 crew members, including his replacement, Greg Shamatoff. This view from the camera on the starboard truss of the International Space Station, you can see the Columbus module on the right side of your screen. Opposite Columbus tomorrow will be a new laboratory. The Kibo Science Laboratory will be installed on the port side of the Harmony module.
All right, Mark. We'll call it 75 feet.
Yeah, well, as soon as we see it.
All right.
Got 75.
Okay.
No low Z.
No low Z.
I see it, and I'm going to give you A10, B10. It's going to tighten up your dead bands.
Okay.
On the far left of your screen, you can see the docking port pressurized mating adapter number 2, and the circular object on the very far left of your screen is the common berthing mechanism on the port side of the Harmony module, to which the Kibo Science Laboratory will be installed tomorrow.
Okay, Karen, I'm going to be putting in a right here in a little bit. We're 50 feet. That was an up.
A preliminary guesstimate on the flyout is that it's perfect right now.
Okay, feel free to get rid of the green crosshair if you need to. Here comes the right.
Actually, though, the crosshair's offset from this, so I need it.
Yeah, just if it's blocking it, we'll need it back.
About 5 minutes to sunrise.
All right. There's a braking pulse.
Okay. And turn this thing off.
We're done then.
Yep. That ain't it. Houston at 35 feet, HHL matches.
Houston, copy.
I think yaw is pretty good.
Yaw looks perfect.
Roll, I see well, now it's looking, about 1 degree left wing down.
Well, see, it looks like it moved since last time I looked at it.
Yeah, it's now it's looking
It looks much better.
Because for a second it looked like it was 2 degrees. Now it's closer to 1. But I think it's still there, though.
Discovery approaching the point at which Commander Mark Kelly has the option of either stopping for an assessment of the alignment of the docking mechanisms or pushing right in for docking.
I want to talk capture for a second. Is that okay?
Let's figure this out, Chris.
All right.
I'm going to do another out.
No, I would say half a degree.
I think, I don't think you need to stop, Mark.
Okay.
Yeah, I don't either.
No fly out. Okay, I'm going to leave the RDOT in there. Let's recapture.
Okay, for capture, I'm going to start an event timer. Aki, you're going to start one as well, right?
I have 1, 2.
Okay. And Aki, your job's
to... First, just pause. Tell them we don't see a fly out.
Welcome. And we're initiating final approach?
Yep.
Okay. And Houston and station from Discovery, we do not see a flyout. We are initiating final approach.
The sun's coming up.
Station copies. And Houston copies.
All right, Aki, your job is to say the capture light is on.
Okay.
I will notify the ground. Ronnie's going to disarm PCT. And flight control power off when they're in free drift.
Okay.
That's it. You're looking for an RDOT of 0.10 plus 0.03. Plus or minus 0.03. Yeah, you're 0.09 or so. You can arm up now.
Getting off the HHL. PCT's arm.
See it.
Copy.
No fly out at all.
10.
0.08.
Yeah, I'm seeing on the slow side.
Yeah.
I might do an in here if I don't think I need a left or a right.
You're within the window though. You're 0.075, 0.08. Yeah, now's probably the time for it.
Well, I'm gonna need a left.
Okay, fair enough.
8.
0.08.
I think we're a foot closer than I'm saying.
And Aki, we might need to go to back to ALC average.
7.
Go down.
0.08.
No, it's good now. If we start to lose it, there's a left.
Okay.
6.
0.09. Looking good. Nice call, Mark. You're gonna need it back the other way too, aren't you?
Back the other way here.
5 feet.
0.09 to 0.10. Right in the heart.
4.
0.09.
Doing up here in a bit.
3. That's wrong.
0.09.
I'm going out the window.
All right. Got my finger.
Pedal to pedal.
All right. I'm going to do a left.
0.09. I agree on the left. You might need one more right to stop it. 0.09.
2 inches. Capture light.
And Houston and station capture confirmed.
PCT's not flashing yet.
You saw that. It's flashing.
Flashing.
Discovery and Houston, ISS is in free drift.
All right.
Copy that. We see the flashing light. Flight control power, Mark.
And Discovery Houston, station free drift confirmed.
You got flight control power?
Yep.
Thank you.
Mark, get a
TCS DAC when we get a chance.
All right.
What's that?
Hey.
Nice.
It's a lot of training, man.
Good job, Mark.
Thank you.
That was a great flight.
Awesome. Good job.
That was fun.
All right. Let's stay on the car.
Okay, Aki, I will work with you.
Okay. How about step 3 right now?
Discovery arriving.
Awesome.
See you later.
Twist around. There we go.
It's all fun and games until somebody loses an eye.
That's right. Or a lock of hair.
I think we got to
get that?
we got to get the cheese cutter.
Did you get that?
That's it.
If there's any pressure, it's going to push the hatch in clockwise. Just keep it from popping.
Good. It's going to come down here towards you, Aki.
Hey, you guys!
Hey, you guys looking for? Hey, you looking for a plumber?
Sorry, it's our lunch break. Come back in 15 minutes.
Oh, man. Let me get this in here.
Pull those lights.
Yeah,
pull
we're
the
gonna pull the lights. Pull the cheese cutter.
Take that one, I'll grab this one. Man, great to see you guys.
Hey, Gary. Good to be here.
You're not kidding.
Smell it.
You all right?
Smell it.
Hey, the WCS
It smells great.
You pull the electrical too,
Hey,
right?
Sergey.
I can wait 5 more minutes.
For now, we can just
lay him in here?
Lay him in here. Ready? Here we go. You ready?
Really, really fast.
Doing fantastic.
Hey,
Great.
Good to be here.
Sergey, how are you? Good.
Thank you guys.
Great to see you. Great job getting her in, guys. Hey!
Hey, Ronnie, look back real quick.
Oh my God! Oh, it's Ricky. How you doing? Michael.
Good to see you, buddy.
Has anybody
Mike, what's going on?
how are you? Great to see you.
Good to see you, man.
That's all you got?
That's all I got. Hey, the WCS is open. And you guys got funnels on the back wall.
Oh, outstanding.
All right, and all you got to do, pick up the hose, put the funnel on.
I think,
Yeah.
actually, Gary already know this, and for us maybe later. I don't know about that. For me, it's maybe later.
All right.
Somebody will
You guys are looking great. Everybody's feeling good, huh?
Yeah.
Good. Awesome. Doing great.
Fantastic.
Great.
Ну что?
Man, you aren't kidding. This place is huge.
This
is just a start, man. You guys are going to make it bigger here in
Hey,
very
we want
short
to
order.
do, at some point we got to do this safety brief. We could also maybe do a quick tour while we're doing the safety
Let's
brief.
start. Done. Let's start our safety brief, and we start safety brief and our tour.
Great.
Right in the time.
Great.
Just for your information, while we'll be going, and we're actually going to start from SM. Try not to touch these ceilings, especially here. You see this rubber ceiling.
The seals.
Seals in the hedge, because it
Might matter later.
And when we enter to the Russian side, first of all, there are some devices, indicator потока, indicator of flow meters actually, on the hedges, and they just velcro to the hedge. Try not to break them. Of course, we check it out before this, but anyway. And be very cautious while you move through the MGB, because it's a mess now. As soon as progress dock, it's a lot of stuff.
Given from progress.
Да. And in SM, it's a little bit, again, a lot of stuff, because while we're doing this ASU repairman,
You're waiting for parts.
Okay, let's start.
And we found the parks, right?
Right. Recall. If you forget it, then
They were misplaced. They were misplaced for today for a little bit, but we got them.
We got him.
Can you hit the pause button?
Oh, it's so clean in here.
Holy cow. Hey, it's the water pond.
Hey, look back. Hot.
Am I really here?
Hot. Look back. Look.
All right, we continue.
Oh.
It's just like building 9.
Oh yeah, from here. Well, I've been here.
It's awfully cooler.
I've been here. Go ahead.
Can't believe it.
Who would have thought?
Who would have thought, man? Who would have thought?
Michael, it's our progress.
Yeah.
Our progress.
Okay. Oh, yeah. Boy, boy.
It's something tempting.
Yeah. for water, for urine, for fresh water.
Yeah.
Get for solid. The next it will be our dragging compartment.
Yeah.
We will do it maybe June, maybe August.
Oh, really?
One exactly, and maybe the second for Soyuz special.
Okay. It's just like I remember. It's so cool. It's amazing.
It's a soft dragging compartment.
Yeah.
And now in our Soyuz.
Yeah. Our Soyuz way down there. Yeah.
It's the same.
Yep. Easy. Easy.
We had this fireball, body fireball stuff right out.
That's good. That's a good piece there.
More important than one there.
Very well be doing a fit check for you later.
Now this is what does not look like building 9.
It's a zero car. So cotton. Usually it's our galley.
It's another reason we're really happy to see you guys is we have hot and kind of warm. It's like really hot and hot. We don't have any cold water, and so what you have to do is you have to make a drink bag and then put it somewhere fairly cold and wait. So you have to plan your like dinner drinks when you wake up in the morning.
Did something break for that?
No, that's just the way.
That's the way it always is.
Yeah.
Okay.
Because our specialist decided that we don't need cold water.
It's not required.
Not required.
You have milk.
Yeah, right.
And there is a central post actually where station crew get together during some emergency situation and actually work in family with this stuff. This is our Cayudas, this is mine, this is Alex. And here we'll have dinner someday, you will have time because we know that you are very busy.
Thank you, Isa.
Leo left us. We're still going. We're still working our way through it.
What is that?
Chorizo.
Chorizo. Wow.
It's pretty good.
Oh, okay. Yeah.
What is it?
Chorizo.
Oh my goodness sakes.
You'll taste on the earth, but here it's delicious.
So you just take a little nibble and be happy.
Okay, if you have any questions here, we have SSCs here, actually, ECS, everything. Our winners, of course, window 9 behind this panel, and this was closed. And who was actually making pictures before the RPM maneuver?
Who was taking the picture?
From your side.
Oh,
it was somebody.
2 of us.
2 of us.
Yeah. Me and Taz. Yeah.
Try to take a picture of, yeah.
Hey, how did the bottom of the discovery go? You know, we were so focused on just doing our shots because it's pretty. To be honest with you, I wasn't really looking at what I was shooting. I was just shooting the zones I was supposed to be.
You know,
but I didn't notice anything.
Yeah, it was gray, just steady gray color. Okay. You can move forward.
You want to show fire extinguishers, gas mask?
Yeah. And then maybe here this. This is Russian style.
Vor wenigen Minuten kamen die 7 Astronauten an Bord der ISS. Im Gepäck der Raumfähre ist ein weiteres Teil des japanischen Weltraumlabors Kibo. Außerdem warten die Bewohner der ISS dringend auf die Reparatur der Weltraumtoilette, die seit über einer Woche kaputt ist.
An Bord 7 Astronauten, ein japanisches Labormodul und vor allem eine russische Toilettenpumpe. Die einzige Toilette auf der ISS ist seit einer Woche defekt, deshalb wird das Ersatzteil dringend erwartet. Hauptaufgabe der Besatzung ist es jedoch, das Labor zu installieren. Schon heute ist ein erster Außeneinsatz geplant.
Die Station hat Besuch bekommen. Dort hat die Discovery am Abend angedockt. Nach 2 Tagen Flug wurden die 7 Astronauten auf der ISS begeistert begrüßt. Sie bringen unter anderem Ersatzteile für die Toilette der Raumstation. Die ist seit über einer Woche defekt. Außerdem wollen sie ein schulbusgroßes Modul für das japanische Weltraumlabor installieren. Insgesamt soll ihre Mission 2 Wochen dauern.